Okay, I think we can start. All right, well, thank you for coming to this talk. I am Rocío Ortega. I work at Habitissimo. Well, let's start with all this Simon Says game like coding. So, how many times have you asked yourself this question when you are about to add a new functionality to your project? Where do I start? Developers deal with daily decision problems that involve huge code bases and little time to come with a solution. In this talk, we will build the famous Simon Says game for Android, and we will show how we can come up with a solution parting from requirements that are turning into very specific test cases. Along the way, we will see the advantages that Kotlin provides us and a really little example of the power that Arrow can add to our project. It's all right. So if you don't remember, or maybe you didn't see that at all because you are too young, this is the Simon Says game. It's a memory skill game. It was created by Ralph Bayer and Howard Morrison, and this game was very popular at the end of the 80s and 90s. And yes, I wanted this game really bad. So how it works? The device creates a series of tones and lights and requires a player to repeat the sequence. If the player succeeds, then the series becomes longer and more complex. If the player fails, then game over. And this is our version of the game. It's quite simple. We will have a start game button, and then the 4 colors: green, red, blue, and yellow. So, where are we starting? Tengo dos. Uno para aquí y otro para acá. No lo sé. Vale.
Encender está encendido. A ver, ¿habla ahora?
¿Hola?
No.
No.
A ver, ¿ahora?
¿Hola? Hi. ¿Ah?
Es que no entiendo el otro.
Lost in translation. Hi? Now better? No? Someone said no and others yes. Hola? 1, 2, 3, probando.
¿Sabes qué pasa? Espera, si vamos a subir un poquito.
Vale.
Aquí, ¿no?
No me voy a mover mucho de aquí.
Vale. Vamos a poner esto. A ver, ¿habla ahora?
Hey? Hi? Fine? Ok.
Lo coloco aquí para que no te moleste. Bueno, no te vas a mover, ¿verdad?
No.
Lo vamos a dejar aquí.
Okay. All right. So, where are we starting? We are going to build this project using MVP, Model View Presenter, Architectural Design Pattern. And in our data layer, we will have a color sequence repository, which implementation will make use of color sequence data source. And we will use this data source to store the sequence of the colors that Simon will give to us. And also color provider that will create a random color every time that we request a color to it. We also have in our data layer a position repository. It will make use of position data source and we will use this position data source to store the pointer that will indicate which color we need to validate each time. Then in our domain layer, we will have our use cases. A start game use case that will start the game adding the first color to the sequence, and then validate color use case. In our presentation layer, we'll have our game presenter that will make use of the use cases to present the data to the view. And our game framework that will be our view. But what are we going to do today here? We are going to work in validate color use case. And why? Because we don't have time to do the whole project. It's too much. And because this use case is the one that has the main logic of our game. For unit testing, we are going to use Mockito. We could use any other library, but it was the one that I am more comfortable. And we said that we are going to use Kotlin for it, so we have to use coroutines. The Kotlin team defines coroutine as lightweight threads. They are sort of tasks that the actual thread can execute. So we are going to use coroutine to handle all of this work of add color, validate color, and so. Coroutines convert async callbacks for long-running tasks into, well, such a database or network access into sequential code. First, let's have a view to some concept for coroutines. Coroutine scope, it defines a scope for new coroutines. That means you can define how long do you want your coroutine to live. Every coroutine builder is an extension of coroutine scope and inherits its coroutine context to automatically propagate both context elements and cancellation. Then we have coroutine context. The coroutine context is a set of various elements. The main elements are the job of the coroutine that represent the coroutine itself and its dispatcher. Dispatcher determines what thread or threads the corresponding coroutine is going to use for its execution. Then we have launch. It is a coroutine builder that will start a coroutine. This coroutine context will be the inherit from the coroutine scope. And finally, we have suspend function with context that calls the specified suspending block with a given coroutine context, suspend it until it completes, and return the result. So let's start putting all these concepts together. We have our game presenter, and because coroutine scope is an interface, we need to implement it. Manual implementation of coroutine scope interface is not recommended, so we should use delegation instead. And the coroutine library provides us with a function main scope that will create a coroutine scope for UI components. The resulting scope has a supervisor job and a dispatcher's main as context elements. Now we can see more examples of how to create coroutine and put everything together. So this function in our game presenter, untiming function, we have created a coroutine using the main context launch extension. It will inherit the context from main scope. Then we will change the context to the IO dispatcher using with context. It suspends the coroutine until it returns the result. And then the coroutine will continue running in the main context, doing something with the result, for example, updating the UI. And we are also going to use a little of flow. Flow is a call asynchronous data stream that sequentially emits values and completes normally or with an exception. So how are we going to use flow? We are going to use flow because we are going to emit the colors in the sequence. So we want to catch each color one by one. So we are going to add a little delay too. And this delay will represent the speed of our game, of the sequence. If we want to change the sequence to go faster, then we can just change the delay time. But for this example, we are going to use always the same time. Then we also said at the beginning that we are going to use a little sample of Arrow. Arrow is a library for type functional programming in Kotlin. And we are going to use a couple of data types. A data type is an abstraction that encapsulates one reusable coding pattern. And we are going to use try. It represents a computation that can result in a result as long as the computation was successful, or in an exception if something has gone wrong. But it was deprecated in the last stable version of the library, so it will be removed eventually in future versions, so we are not going to use that. Instead, we are going to use for this example option. Why? Because in this case, it's the pattern that make more sense for this example, no? For this game. So we are going to use option, for example, when we request a color to the color sequence repository. Maybe we have the color, or maybe we don't have the color. So that's why I'm going to use option there. So how it represented in code? So if the value of type A is present, the option A is an instance of sum, containing the represent value of type A. If the value is absent, the option A is the object num. We are going to also use validated data type. This data type can be used, for example, to validate forms, validate a phone number, and in our case, we are going to use it to validate the color the player is entering in the game. How it represented? Validate represents a computation that can result in a valid B result, or in an invalid A if the validation was wrong. And how can we unwrap these two data types and get the actual result? Open the box. We can use fall. In case of option data type, the operation will extract the value from the option or provide a default if the value is none. And for validated, it will work the same way. So in conclusion, we can unwrap this from the two data types using fall. So the first block will run if something was wrong, we don't have the value, or it was invalid. And the second block will run if we have the value, or in case of validated, it was right, the validation. Here a little disclaimer. There are more solutions for the same problem. There are a lot of tools. There are a lot of architectural design patterns to use, but these ones are the ones that I have used. So let's start. Okay. I just need to switch. Okay. Let's have a look and see if I have everything in order. Yes. Okay. So let's start. Yeah, it's fine. Yeah. First, we are going to go to our game presenter test. No. Well, yes, we are going to navigate there, but sorry. First, we are going to run our app. Oh. Let's put it. Okay. It's fine. It's waiting for it. Come on. Yes, this is what usually happens when you want to do something live that you were trying at home so many times that everything was working, but now it's like, I don't know. Okay. Okay, now. Okay, so this is our game. Let's see what we have already. So let's click on Start Game. And then the first color was added to the sequence. It was yellow, so let's click on yellow. And if the game is working, then another color should be added to the sequence. Okay, nothing's happening. If I click on the wrong one, so it's because it's not doing anything. So let's go to the code. And first, let's run our game presenter test. And we can see that we have already 2 tests, and the 2 of them are green. So it said, game presenter should hide a start button when on start game. So we have seen that, it was working. Game presenter should render first color when on start game. Yeah, we have seen also that the first color, the yellow one, was added to the sequence. Okay, so now the next the test that we want to write will be that we want the presenter to render game over if green color, for example, is not correct. So we want to verify that when we call, well, the render game over will be called if we enter the green color. So now if we run the test again, we can see that the test is failing. It's a wanted but not invoked. Okay, so let's have a look to our production code. And it is calling color press green. Okay, so it's empty. So we need to do something here. So what is the minimum piece of code that we can add to this function to make our test pass? It's easy. We can just call view render game over. So if we run the test now, all green, cool. So let's go back to our test. And then what we want to do is add a new color in case we enter the correct color. So for that, presenter should render a list of colors, no? Because we started with one color, so it should add a new one if the green color is correct. So we said that it should be, no, it should render the 2 colors, first green and then any other color. So we need to test that we are calling this color in order. So for that, we can verify that first we are gonna call green and the next one will be red. Okay? So we just need to call presenter on green press, and then if we run our test, we can see that that test is failing. It said wanted but not invoked. However, there was exactly one interaction with this mock. Okay, so let's go back to our production code. And yes, we are always calling render game over, so that's why it's failing. So now is when we need to start interacting with our verify color use case. All right, so we wanted to do all this job using Corroutine, so let's launch our Corroutine. So we launch the Corroutine, we change the context of the Corroutine with context, we call verify color. Verify color will return a validated of unit of list of color. So if it was invalid, it will return an invalid of unit. But if it was a valid color, it will return a valid with the updated list of colors. And we also said that the first block of the fall will run in case it was invalid, game over. So we need to call here render game over. And then the second block will run in case it was a valid color. Okay, but we also said we are receiving a list of colors, but we want to emit these colors one by one to the view. So for that, we can convert this list of color into a flow and emit it. So for that, we can do that. We will see what it's doing as flow with delay later. And when we collect the color, we just need to render that color. Okay, so as promised, let's have a look to as flow with delay. This is a private extension function that I have created for iterable. And what it does is create a flow. And then for each element in the list, it will add this delay time that will determine the speed of our game, and then emit the color. Okay, so now we can run the test again and see what we have. Okay, we have 2 errors, 2 of the tests are failing, and it's because we are interacting with our verify color use case, but we are not mocking the response. So the only thing that we need to do now is just mock the response of verify color in each test. So in case it should be invalid, we can call verify color. It was green, the color that we wanted to verify. And then it's return an invalid of unit. And for the second case, we have to do the same, but instead of return an invalid is to return a valid with a list of color. In this case, the first color we said that should be green, and the next one should be red. Okay, so if we run now our test, we have everything green. So now we can run again our app, and let's see what we have. So start game, first color added to the game, it was blue. So if we click on blue, it's a game over. Okay, let's run it again. Oh, if you click 2 times, then that is what happened. Okay, game over. So let's go to our production code again and see what is going on. So we go on color press. So let's see what is doing verify color. And verify color is always returning invalid. So now is the moment when we start building our verify color use case. So first, let's go to our test, verify color test, and write the first one. So verify color should return invalid when color is not correct. Okay, so let's call verify color, color green, and then we need to assert that result should be invalid. Okay, so if we run our test now, green, cool. So now the next one should return valid when the color is the correct one. Okay. Oh, first call verify color, and then result should be valid. Okay, if we run our test now, the second test is failing because we already know that in production we are calling all the time invalid. Okay, so let's see what can we use in our verify color. We can use color sequence repository and position repository. So let's have a quick look to color sequence repository. With color sequence repository, we can create a color, we can get color at any position, and we can get the full sequence of color or reset, so remove all the colors in the sequence. And we also have position repository. And we can get the current sequence position. Think that position repository will help us to have like a pointer saying which is the color that we need to verify each time. So we have get current sequence position. We have increment sequence position that will point to the next color, and then reset sequence position. So we can start again from the first position of the color sequence. All right, so knowing that now, what can we do to know if we are clicking on the right color? We need to get the color that is already in the sequence and compare with this one. So for that, first we need to know which position we need to evaluate. So when we call position repository get current sequence position, then we can make it return 0. That will be the first one, for example. And then we can get the color from the color sequence repository at that position. So color sequence repository get color at that position that we set 0, and then it should return, and get color at is returning an option. So in this case, we want to return an option of just the same color that we are validating. This is green color. All right. So, well, we can run again our test. It is going to fail because we didn't change the production code. And now we can go to our production code and start writing here something. Okay, so we said that we first need the position. So just we can color position repository, get current sequence position, and then we can get the color at that position. So we can call color sequence repository, get color at that position, and then because we said get color at is returning an option, we can filter and compare that color is the same as the one that we are entering. And now we can fold to get what is inside of the box. So the first block we run in case it is not the correct color. So let's return invalid of unit. And then the second block will run in case it was the correct color. And we are expecting a list of color, but right now for this test, we don't care, so we can just create a list of just the color that we are entering. Wait. Or the one that we get, for example. Okay, so we just can move this return here. All right, and then run the test. So now we have the first test is failing, but the last test is green. So if we go to our test, we can see that what we need to do is mock the response position repository and color sequence repository. So we are returning the wrong color. Well, yes, a different color from green. So before that, we can just refactor this a little bit so we can extract the position, and then we can do the same thing with the color. Only this one. Okay, move it here, extract this as a function. We can call it, for example, whenever color at position. Okay, just inline now this, and this one too. And then we can copy this, move to this test, And instead of return green, we can return any other color. So red. Okay, it's failing because it's expecting only the green color. Now, it's fine. Okay, so if we run our test again, all green. So let's have a look and see how it is doing our game. So we click on Start Game. First color is added, red. Okay, now it's not saying nothing about game over, so that is a big step. But it's returning the same color. It's not adding any new color to the sequence. So now the next step is, in case it is the correct color, then we need to add a new color to the sequence. All right, so let's go to our test and write this next test. So verify colors to return a list of colors when color is correct and it is end of the sequence. Why is that, this end of the sequence? Because, for example, if we have the game is render a list with two colors, green and red. But we want to validate, we are validating just the last color in the sequence. Then in that case is when we need to add a new one. Because if we are checking just for the first in the sequence, we don't need to add any new. We just need to wait until the player complete the sequence to add a new color. So that's why the end of the sequence thing. Okay, so it's return the list of color. We need to compare the result that it will be this list of color. So for that, we can get the result. We need it. So first we need to call verify color. And then we need to assert that the result will be a list of color. Could be green, I like the green color, and red. That's why I always use this one. So yes, we need to compare that. So first it said that it should be the correct color. And we already know that with this condition, we have the right color. Okay, and now we need to check if we are at the end of the sequence. So for that, we need to know what is the position that we need to evaluate and how big is the sequence of colors. So for that, because we are at the first position, then when we ask the color sequence repository for the whole color sequence, this should be a list of just one color, green. So we will be at the end of the sequence. Okay, so it's the correct color, we are at the end of the sequence, but now what we are expecting is a list with two colors. So we need to add the new color to the sequence. So for that, we can first call add color. So whenever color sequence repository create color, and this new color should be red. So it will return an option of red. So the second time, because we have added the color, but then we need to request again to the color repository the updated list of color. So the second time we call get color sequence, then we will get the updated list with green color and red. All right. Okay, so let's run. No, it's gonna install the app. No, I wanted to verify color test. Okay. It is failing because we didn't change the production code. So let's go to the production code and just check if we are at the end of the sequence. So for that, okay, end of sequence. It will return an option of unit. Okay, so first we need the position, but for that we can just use the one that we have already asked. Okay, and we need the size of the sequence. So size will be color sequence repository, get color sequence, give me the size. And if the size, well, if the position is equal to size -1, then it will return an option, an option of just unit. Otherwise, it will return empty. Okay, we can do that. So we said that if the color is valid, then we need to see if we are at the end of the sequence or not. So we can here call end of sequence, and then full. So if we are at the end of the sequence, well, if we are not at the end of the sequence, the first block will run. So right now we can just do this. We'll come back later. In case we are at the end of the list and the color was valid, then we need to add the new color to the sequence. So let's do that. Okay, fun, add color to sequence. And it will return the updated list of color. So it will be a list of color. Okay, so for that, first, add the color sequence repository, create color. And after that, we can just map it and call color sequence repository, give me the updated list of colors. Okay, and we want to do this only if we are at the end of the sequence. So for that, we can use flat map here and call add color to sequence. So now, instead of return here unit, we are returning the updated list of color. And we can just return valid of this updated list of color. So it will run now our test, all green. Okay, so let's go back to our test. And now, if we are not at the end of the sequence, then we don't need to add any new color. We just want to return an empty list because we want to say, okay, it was correct, but I don't want to render any new color or render anything, just wait. Okay, so it should return an empty list when the color is correct and it is not the end of the sequence. So we can, just because I don't have too much time, I'm going to copy and paste that. So instead of a list of green and red, it will be an empty list. Okay, of colors, don't complain. Okay, it is the correct color. And we need to know if we are not at the end of the sequence. So in this case, when we call color sequence repository, give me the full sequence of color, then it should return a list of color where the first color is green, and we also have any other colors in the list. In this case, red. Okay, so if we run now our test, it is going to fail. It said that we are expecting an empty list, but we got just one color. So let's go to our production code, and that means that here we are returning always this list with that color. So instead, we just need to return an empty list, and that's it. So let's run our test, and now we have everything green. Okay, so let's go and have a look to our app again. Start game, green color added, green color added twice, so we added the new color to the sequence. But something is wrong, no? Something is missing here. So we are checking all the time that we are at the first position, but we are not moving the pointer to the next position in the sequence. So that is what we need to do now. So we go back to our test, and what we need to do now is, in case that we are not at the end of the sequence, we need to move the pointer to the next element in the sequence of colors. So verify colors should increment the position when it is not end of sequence. Okay, so we want to verify that position repository increment sequence position when we are verifying the color green and we are not at the end of the sequence. So just to save a little bit of time. Okay, so if we run now our test, well, it's going to fail because we are not calling position repository increment sequence position. So let's go to our production code. I can remove this. No. Okay. So if we are not at the end of the sequence, that means here we need to increment the position in the pointer in our position repository. So let's call increment sequence position. If we run now our test, all green. So let's go back to our test, and now if we are at the end of the sequence, then the new color is added, and we have to start validating from the beginning again. So we need to move this pointer to the first position. That means that it should reset the position when it is end of the sequence. So here we call verify color, position repository, reset sequence position. Let's call verify color. Let's remove this. And it should be the correct color. So let's copy and paste. Sorry about that. The good way to go here is refactor a little bit the code so you can reuse this. But I had that planned, but I don't have time. So, okay. We run the test, it is failing because we are not calling reset sequence position in our production code. So if we go back to it, then we said that we should be at the end of the sequence to reset the position back to the position 0. So then here we should call reset sequence position. Let's run our test now. All green. Let's go now to our game. Finger crossed. Start game. First color added, it was red. Red, then blue. Okay, so we have our game done. It's working. If I click in a different color, then game over. Oh man. So just to wrap it, conclusion, we have turned in requirements into unit tests. We have used coroutines in our game presenter. We have used a little bit of flow to emit the colors. We have used a couple of arrow data types. And we have built our Simon's game. Thank you very much for coming and for listening to this talk. If you want to to play also with this, you have my repository there in GitHub, or if you want to ask something, this is my Twitter account. Yes, again, thank you for listening. Yeah, thank you.